in the last lecture we have studied about the RL, RC, RLC series circuit concept of impedance we have covered, right? And we have covered active power, reactive power, apparent power, power factor, power triangle, right? Now in the today's lecture we'll cover the topic that is resonance, quality factor, half power, frequency, bandwidth. In this you need to learn about only the formulas, and by the formulas you'll get all the questions solved. Okay, so first of all I'm telling you about the resonance. Resonance is basically a condition. What is that condition? In this condition XL is always equal to XC. What is XL? As you already know, that is, we are having inductor and there is some amount of resistance present in the inductor, that is known as XL. Similarly, there is some amount of resistance present in the capacitance, that is known as XC. So if both are equal, then in that case the resistance is means if both are equal, then in that case that is the condition of resonance, right? This is first condition. Another condition, if XL is equal to XC, then normally the formula of impedance is what? Z is equal to root of R square plus XL minus XC ka whole square, right? But if XL is equal to XC, then in that case Z would be equal to R only. Yes or no? Z would be equal to R only. Now the next condition, if Z is R, then in that case impedance is minimum or maximum? Tell me. If Z is equal to R, earlier the impedance was this one, right? After applying the condition of resonance, the impedance will become equal to resistance. Z is equal to R. So in this case impedance is minimum or maximum? Minimum. Now it is decreasing, minimum. So in condition of resonance impedance is minimum, and if impedance is minimum then current will be maximum, correct? Because resistance and current are inversely proportional to each other always, right? Got it? So in this case this is the basically condition of resonance where XL is equal to XC. Now for this case there is a different resonant frequency, and we need to calculate resonant frequency from this condition only. As you know, XL is how much? XL is equal to 2 pi FRL, XC is equal to 1 by 2 pi FRC. So FR formula is what? Can you calculate the FR formula from here? So in this case FR square is equal to 1 by 4 pi ka square LC. So FR would be how much? 1 by 2 pi root LC, right? So this is the formula for the resonant frequency. Note it down, this one. Next there is a quality factor. Quality factor is denoted by Q. Okay, quality factor is denoted by Q factor or Q. That is completely different from power factor. Okay, power factor is what? Cos phi, and cos phi will have R by Z. So don't confuse power factor and quality factor. These two are separate terms. If they ask you the quality factor, then that means that would be the condition of resonance definitely. Okay, so we'll have particular formula for the quality factor. Quality factor, that is voltage drop across L or C divided by the applied voltage. Okay, so voltage drop across L or C is how much? I into XL or I into XC divided by applied voltage is how much? I into R. If I substitute the value, suppose XL over here, so XL value is what? 2 pi FRL. As you know, it's a resonant case, so I by R, I would be cancelled. Again, if I'll put FR value is 1 by 2 pi root LC, then we'll get the final answer of the quality factor is 1 by R root L by C. So this formula of quality factor, you need to learn it from numerical point of view. After this we'll do the numerical. First write down all the formulas. Okay, after this we'll have another formula of quality factor. Quality factor is resonant frequency divided by bandwidth. Okay, resonant frequency is FR. Bandwidth is what? Bandwidth is basically, suppose we'll have a graph curve like this, that particular current is maximum at resonant frequency. Okay, so there is two range of frequency, one is omega 1, another one is omega 2. So in this case bandwidth is how much? W2 minus W1, where W1 is the lower half power frequency and W2 is upper half power frequency. Okay, so this you need to remember the formula for the quality factor. One is FR by BW. BW is bandwidth, and another formula for bandwidth is W2 minus W1. Okay, we'll have separate formulas for W1 and W2. That is, again you don't need to do derivation, you just need to remember the formula. Minus R by 2L plus root of R by 2L का whole square plus 1 by LC. This is omega 1, this is omega 2. Another one is R by 2L minus 2 R by 2L minus R by 2L का whole square plus 1 by LC. If we'll multiply omega 2 by omega 1, then answer will be 1 by LC. But if we'll subtract omega 2 minus omega 1 is R by L. Okay, and another formula of if suppose normal frequencies is given, another formula for bandwidth is R by L. So that depends ki whatever they have given, according to that we have to use the formula. There is one more formula for the quality factor, that is VL, voltage across inductor, divided by bandwidth. Okay, write down this formula as well. Again that depends on what they have given in the question. And here in this case L is equal to 2 into R divided by 2 pi FR. Basically they have solved this thing only, so don't write down this formula, write down this one only. Now let's see the numerical based on the resonance which comes in Manipal exam. They said it's a series RLC circuit where R is equal to 10 ohm, L is equal to 0.01 Henry, capacitor is equal to 0.01 microfarad, is connected across 10 millivolt supply. Okay, they said what you need to calculate: resonant frequency. Resonant frequency is FR, right? Then they ask you to calculate quality factor, means Q factor. Then they ask you to calculate bandwidth, that is BW. Then they ask you to calculate half power frequencies, that is omega 1 and omega 2. And finally they ask you to calculate current for the resonance condition. Okay, try it. See, this is the question from your paper only, from April 2019. This is the resonance based question. In this they said R, L, C all are given and the voltage is given. First they ask you to calculate resonant frequency. As I told you, the resonant frequency formula, that is 1 by 2 pi root LC, right? We have L, we have C. C we need to convert it into the standard unit, that is 0.01 into 10 raised to power minus 6, right? So if we'll solve it, then we'll get the value of 15915.49. Got it? Next is quality factor. Micro is 10 raised to power minus 6 and milli is 10 raised to power minus 3. Milli. 1 millihenry is 1 into 10 raised to power minus 3. 1 microfarad is 1 into 10 raised to power minus 6. 1 megahertz is 1 into 10 raised to power plus 6. 1 picofarad is 1 into 10 raised to power minus 12. 1 kilo ohm is 1 into 10 raised to power plus 3. 1 milli हो गया. Okay, understood? Now after solving it, we'll get this one. Next is quality factor. Quality factor, I told you 1 by R root L by C. R is given, L is given, C is given, you will get it 100. Bandwidth, I told you R by L. Okay, R is given, L is given, you will get it in 1000 radian per second. But if you want to calculate bandwidth in hertz, then the formula is R by 2 pi L. Then you will get 159.19 hertz. See, I told you the formula. Omega 2 minus omega 1 is equal to bandwidth only, right? Bandwidth is equal to omega 2 minus omega 1, and that is R by L. But this will get it in radian per second. If you calculate bandwidth R by 2 pi L, that would be in hertz. So that depends on you, whatever they ask or whatever you want to calculate. Next is half power frequencies. Half power frequencies means omega 1 and omega 2. I told you the formula of omega 1 and I told you the formula for omega 2. You can just substitute the value and then you will get the answer. I'll tell you the answer. Omega 1, you will get it as 99501 radian per second, and omega 2, you will get 100501.5 radian per second. Current at resonance, you know the general formula for current is V by Z, but in resonance case Z is equal to R, so it's V by R. Is 10 millivolt, 10 into 10 raised to power minus 3, resistance is 10, so you will get current as 1 milliampere. See, in this question, the question from 2024, bandwidth is given, how much, 200, resonant frequency is given, 4000, and R is given. First you need to calculate XL, right? So you know the bandwidth formula, bandwidth is equal to R by L, right? Bandwidth you know, R you know. Can you get L? So if you'll get L, then XL is equal to 2 pi FRL. You know, pi you know, FR is resonant frequency is given, L calculate it, then we'll get XL, right? Next is quality factor. Quality factor is what? I told you the formula, that is bandwidth is equal, quality factor is resonant frequency by bandwidth, right? FR divided by bandwidth. FR we know, bandwidth we know. Next one is the LV, XL is equal to XC, right? They ask you to capacitance of circuit at resonance, so XL is equal to XC. So XL we know, we have calculated from here, and XC is equal to 1 by 2 pi FRC, right? FR we know, that is given 4000 hertz. Can we get C? So after solving, I'm telling you, L you will get it as 3.98 millihenry. Solve it in your homework. C you will get it as 0.398 microfarad. Bandwidth you will get it as 20. Okay, and yeah. Next is voltage drop across inductor at resonance if supply is 100 volt. So voltage drop across inductor means VL. VL is equal to I into XL. Current is given? No, XL is not given. So we need to calculate VL. We'll see if there is another formula for VL, that is quality factor is equal to VL by bandwidth. Quality factor you know, bandwidth you know, and VL you can, right?